empirical formulas, percent composition, subject of today, empirical molecular formulas. All right, so percent composition is something that's easily calculated. It's the mass of the elements in that compound divided by the total molar mass. So, by the way, if you don't have a periodic table handy right now, take a second and find one, because you're going to need the periodic table. Of course, you've got one right there on the wall, but if you want your own. Mass of the element in the compound is just whatever that molar mass of that element is times however many of them you have. So this looks complicated and it looks really difficult when you look at it like this, but when you see an example, you'll see how easy it is. Okay, it's mass of the element in the compound divided by the total molar mass. Like I said, it looks really challenging. When you read that, you go, blah, but it's actually not that bad, I promise. So I'll give you a second to jot that down, and then we'll do an example. Mass of the element in the compound divided by total molar mass. So here's an example. What percent of ethane is carbon? All right. So I want to know what percent is carbon. I'm not interested in what percent hydrogen, although I could find the percent hydrogen pretty easily because all these percents will add up to what number? 100, right? So if I figure out what percent's carbon, I could subtract from 100 to get hydrogen. So percent carbon, right? This is the mass of carbon in ethane. The formula is C2H6, right? So therefore, carbon's molar mass is 12.011, and there are 2 carbons in ethane, so 2 times the molar mass of carbon, right? Now, where did this 30.07 come from? What's that? That's just the total molar mass. Does everyone see how you do this? It's the molar mass of the element that you're interested in times however many of them are in that molecule, divided by the total molar mass, and then times 100, because it's a percent. So this would be 80%. And then to get percent hydrogen, I could do it the exact same way, right? 6 times 1.008 divided by 30.07, that would work. Or I could just subtract 80 from 100, right? Get the same answer either way. Does this make sense? Element of interest divided by total molar mass. All right, so you try this one. What's the percent nitrogen in calcium nitrate? Percent nitrogen in calcium nitrate. I'll pause the recording while you work on this one. All right, so we need to know the formula for calcium nitrate, right? Calcium nitrate would be CaNO3(2). So there's its total molar mass. And then the mass of nitrogen would just be 2 times 14 divided by 164. Do we agree? 17.1%? Very good on this. Do you want to try one more, or are you good? Good? Okay, let's go on to another one then. Now, the formulas tell you the mole ratios of the elements in that formula. Okay, so we're going to come up with a way to get these mole ratios today. So we're going to calculate first what's called an empirical formula. An empirical formula is the formula that has the lowest ratio of elements. Right? So if you think back to your elementary school days when you're learning about fractions, right? 4/8 and 1/2 are the same proportion, right? But 4/8 is not reduced. 1/2 is reduced, right? So you would think of, in terms of empirical formulas, you look at the ratio. The ratio 1:1 does not reduce any further, right? Does the ratio 6:6 reduce? The answer is yes, right? 6:6 reduces to 1:1. So that would mean CH is the empirical formula of C6H6. Does this make sense? So just ask yourself, does it reduce or does it not reduce? If it reduces, then it's not an empirical formula. If it does not reduce any further, then it is an empirical formula. Now, a molecular formula, on the other hand, does reduce. Molecular formula is an empirical formula that's been multiplied by some number. Right? So if we go back to our previous example, how do I go from CH to C6H6? Well, I just multiply everybody by 6, right? That would mean CH is the empirical formula, C6H6 is a molecular formula. Do we see the difference between an empirical formula and a molecular formula? Molecular formula would be like 5 out of 10, 5/10, right? Whereas empirical formula would be 1/2. Does this make sense? Is this reasonable? Everybody understand how to do this? Or see the difference, I should say. Because I haven't done anything yet. Does everybody see the difference between empirical formulas and molecular formulas? Molecular formulas can reduce, empirical formulas cannot reduce. So let's just shout out these answers. You tell me, are they empirical or are they molecular? CCl4, does the ratio 1 to 4 reduce any further? No, so what would that be? Empirical, right? If it does not reduce, it's empirical. SO2, does that ratio reduce any further? No, so what's that? Empirical, right? N2O4, does that ratio reduce? Yes, 2 to 4 reduces. So is that empirical or molecular? Molecular. CaCl2, empirical or molecular? Empirical. C2H6, empirical or molecular? Molecular, good. I have the answers there. Everybody good on how we do this? You just look at the ratio and ask yourself, does it reduce? Yes or no? Okay, so we're going to use data that are gathered experimentally, and we're going to calculate empirical formulas. Okay, now I will give you these data. So anytime you see a whole bunch of percents given to you, that should tip off to you, okay, I need to use this method to calculate to calculate empirical formula. So here are the steps. Now it looks a lot more complicated than it really is. I will give you these percentages, right? That's got to be given to you. And then we're going to pretend that we've got a 100-gram sample. Here's why. If you've got 100 grams of a sample that's 55% carbon, then that means you've got 55 grams of carbon, right? If you've got 100 grams of a sample that's 45% hydrogen, that means you've got 45 grams of hydrogen. So what you do is you just take all these percentages that I'm going to give you and just replace the percent with a grams, okay? Replace the percent with a grams, because we're just going to imagine that we've got 100 grams of our sample. Now we're going to convert everybody grams to moles. Okay, we're going to convert grams to moles for everybody using the molar mass from the periodic table. And then we're going to look at those answers that we get in step 2. We're going to pick the smallest one, okay? And we're going to divide all the other ones by that smallest number, all right? And then once we've divided everybody by the smallest number, we will round to the nearest whole number, unless we get a number ending in 0.5, then we'll double everybody, or if we get a number ending in 0.3, and then we'll triple everybody. So I will show you examples of this, but I just want you to see the overall picture first. All right, so we're pretending we've got a 100-gram sample. We're converting to moles using molar mass. We're dividing through to get the mole ratio to give us an empirical formula. So let's do this one together. Now I'd have to give you these percentages, okay? So anytime you see a whole bunch of percents given to you, that should be a screaming siren to you that this is the method to do. All right, so what is the empirical formula of a compound that is 71.65% chlorine, 24.27% carbon, and 4.07% hydrogen? So the first thing we're going to do, we're going to pretend that we've got a 100-gram sample, and we're going to convert grams to moles for everybody. So the molar mass of chlorine is 35.45, molar mass of carbon is 12.011, Molar mass of hydrogen is 1.008. Now, it's not normal that you get two numbers the same. That's a very rare occurrence that you get two values to be the same, but it happens from time to time. Now we're going to pick the smallest number. 2.021 is smaller than 4.04. So we're now going to divide everybody by the smallest number. Now this comes out to be 1. This comes out to be 1. This comes out to be 2. There's no 0.5. There's no 0.3. So I don't need to worry about doubling or tripling. I just go about my merry way. However, what if this had come out to be 1.5? What if this one came out to be 1.5? That's like 1.5, right? So you would double everybody to get rid of that 0.5, okay? If this came out to be 2.3, that'd be like a third. We don't like having thirds. So we'd triple everybody to get rid of that 0.3. But none of these came out to be 0.5 or 0.3. So we don't have to do any doubling or tripling. So there's our final answer. The subscript of chlorine is 1. The subscript of carbon is 1. The subscript of hydrogen is 2. And that's my final answer. Does this make sense? So here's what I'm going to do since we're getting a little low on time. What I'm going to do is I'm going to skip ahead in how to take an empirical formula and turn it into a molecular formula. Show you how to do that. Okay. And then Wednesday, all we're doing on Wednesday is enrichment on this. Okay. That way I get through all the empirical formulas, I get through all the molecular formulas, I get through all the calculations today. I won't give you any practice problems to do in class today, but all day Wednesday will be enrichment, so you'll get your practice then. But since we're getting kind of low of time, I don't want to do practice problems on this and then not get to molecular formulas. I don't want to have enough time to do both today. So we'll skip the in-class problem on this, and then we'll do empirical and then molecular, and then we'll have all day Wednesday for enrichment. So let me skip to molecular formula. Now this is using the exact same empirical formula that we just figured out. So remember, the difference between an empirical formula and a molecular formula is that a molecular formula does reduce, whereas an empirical formula does not reduce, right? 4/8 and 1/2 are the same proportion, right? How do you turn 1/2 into 4/8? Just multiply everybody by a factor, right? The same thing is going to hold true for converting an empirical formula into a molecular formula. So this is the empirical formula we just came up with, right? We just came up with this 5 seconds ago. If a compound has the empirical formula CH2Cl, now I would have to give you the molecular formula. I have to give you this molecular formula. That has to be given. What is the molecular? If the molecular formula has a molar mass of 98.96 grams per mole, what is the molecular formula? So what we need to do is we need to come up with the factor that we're going to multiply by. And so that factor is really easy to obtain. The way we get it, I'll pull the screen back down in just a second. I just want you to see the formula. The factor that we use is the molar mass of the molecular divided by the molar mass of the empirical. Now this you have to be given. Okay, that's got to be given to you. You can't do this without that. And then this, you calculate. A molar mass of molecular divided by molar mass of empirical gives us the number that we then multiply by. So in this problem, if a compound has the empirical formula CH2Cl, which is what we just figured out in the previous problem, and its molecular formula has a molar mass of 98.96, okay, that's what's given to me. How do I turn this empirical formula into a molecular formula? Well, I have to figure out what number I'm multiplying by, right? So that 98.96, that came directly from the problem, right? That was given to me in the problem. And then where did that 49.48 come from? Right, that's the molar mass of the empirical. Right, carbon is 12.011, hydrogen's 1.008, and there are two of them. Chlorine 35.45. So I just added those all up. This divided by this rounded to the nearest whole number is 2. So that's what the factor is. Now I just multiply all my subscripts by whatever that factor is. So if the empirical formula is CH2Cl, multiply that by 2, that gives me C2H4Cl2. You can always ask yourself, is it empirical or is it molecular? Does the ratio 1 to 2 to 1 reduce? No, it doesn't, right? But does the ratio 2 to 4 to 2 reduce? Yes, that does reduce, right? So your empirical formula should not be reducible. That's a self-check. Your molecular formula should be reducible. If you get a molecular formula that is not reducible somehow, you know you made a boo-boo, probably in figuring out what your factor is or in figuring out your empirical formula in the first place. Okay? So that's where we're going to stop with the lecture portion. Wednesday, come prepared. We're going to do enrichment on this. I'll give you data. You'll do the arithmetic, and then you'll figure out your empirical formula and then turn it into molecular formulas. So that's where we'll stop. Have a good day, and I'll see you Wednesday.